Hello, good morning, all of you. Let us start physics today. Okay, today is 16th, sorry, today is 17th of August. In the previous video classes, we were doing sound, chapter number 7. In your textbook, it is on page number 146. Okay. Now, recently, the council has given the reduced syllabus for ICSE 2021. In that reduced syllabus for the next year, ICSE 2021, in the sound we have got three headings that we have discussed. The first one is called the reflection of sound. In that we have studied about echo. We have also derived the formula for the echo, and we also solved some numericals on echo. Okay. Then the second part in the sound is the vibrations. In the vibrations also we have learned there are three types of vibrations. The first one is your natural or free vibration. The second one is the damped vibration, and the third one is the forced vibration, which is the application of resonance. You have to study that, and we have already discussed it. Now today, the third segment of the sound is the characteristics of sound. Now, this topic I am going to discuss today, the characteristic of sound. It is not a new topic for you, because the sound in physics it is already there in class 8 and class 9. So it will be a kind of revision for you. In the reduced syllabus, you just have to study what are the characteristics of sound, and on what factors these characteristics depend. So let us start now the characteristics of sound in detail. We all of you know that sound travels in the form of waves. The wave pattern is produced. Characteristics of sound. The sound waves produce, or it has got three different characteristics. The first one is loudness. Sometimes this loudness can be also referred to as intensity, but these two quantities are slightly different, so we will only focus on loudness. The second characteristics is pitch, or it is also called shrillness, how shrill the sound is. And the third characteristic of sound is quality, or it is also called the timbre. Okay. Now, loudness. Let us go to the first characteristic of sound, loudness. Let me discuss that loudness now. Now what happens is, in order to discuss this characteristic loudness, there was a small experiment done by using two instruments. One is the microphone, and another is one box which is also called CRO, that is cathode ray oscilloscope. Okay, so in order to get the pattern, or in order to understand the loudness, let us take this small experiment. Suppose you have a microphone here, or a mic, something like this. Okay, and you have one box. This is not exactly a sound box, but it is which gives you the pattern. Okay, so that is also called the CRO, cathode ray oscilloscope. Okay, now you have one input here, which is also known as Y input, Now this microphone is connected to this through the help of this. Okay. Now any sound that you want to produce, so that you get these characteristics, okay, you get to know the characteristics of the sound. So that sound which is to be produced is brought near the microphone, and from the microphone you will enter this CRO, and in the CRO the wave pattern is obtained. You have a screen here, and in the screen you see the wave pattern. Okay, so now let us go to the first characteristics, loudness. Basically, what is the loudness? Loudness is the characteristics by virtue of which, or due to that property, a loud sound can be distinguished from a faint or a soft sound. The two sounds may be having the same pitch and the same quality. These are the two characteristics which we will come to it later on. So it now basically distinguishes or differences between a loud sound and a soft sound. Now what happens here is, suppose you take a tuning fork. In the last class we were discussing regarding the vibration tuning fork. Suppose this is a tuning fork, and you bring it near the microphone and you strike it softly, very soft. Then what happens is, in this CRO you will see some pattern obtained on the screen. Okay, then you see a pattern, then you make that pattern there. Suppose in the CRU you make the displacement time graph. Last time we have discussed this displacement time graph. Okay, this represents the time x-axis, and this represents your displacement or amplitude. Now in the first experiment what we did is, we brought a tuning fork near the microphone, and the tuning fork is struck very softly. Now you get on the screen of the CRO one, let us say this is formed, displacement time graph is formed, something like this. Okay, then in the second case you take the same, what you call a tuning fork, and now you strike it with more force, or you strike it a little bit hard. Then what happens is, let us take the same, then you will observe that this is for the soft sound, and this is for the loud sound. Okay, now looking at this graph, two graph, what do you understand here is, the loudness is that characteristics which distinguishes the loud sound from a faint or a soft sound. So by looking at this graph, what is the factor the loudness depends on? It depends upon the amplitude. Look at the two graph. There the amplitude is very less. So if you have a less amplitude means you produce a soft sound, and if you have a higher or more amplitude means you produce a loud sound. So basically we come to one point, the loudness depends on the amplitude. Okay, so we have other factors also. Now how the loudness can be measured? Basically loudness is the subjective quantity. It depends upon the sensation of the receiver or the perceiver. So loudness can be measured in a unit which is called the decibel, or sometimes it is also called the phone. Loudness depends on the unit, that is called phone, PHON, phone. Okay, let me check this. So this is the small setup in order to understand the characteristic of sound, loudness, by looking at the screen. In the first case and in the second case we observe that it is depending on the amplitude. So now let me rub this. So what do we understand here is, Loudness basically it depends on amplitude. That is the first key point. It depends on amplitude, and if it crosses a certain loudness level, then we call it as noise pollution. So that is how we measure the loudness. It is measured by using a unit. The common unit is decibel, small b, small d, and capital B. So we write like this. So we can say that suppose during the takeoff of the aeroplane from the air, from the say runaway, it makes a huge sound. So that loudness is measured in decibel. There is another unit also which is not used that often, but it can be also learnt. It is called phone. Now we go to the main topic on the loudness. On what factors does the loudness of a sound depend? So basically there are 5 factors. Let me do that quickly. Okay, so let me do that quickly. Factors on which loudness of a sound depends. Number 1, it depends directly, it is directly proportional to the square of the amplitude. So loudness is directly proportional to the square of the amplitude. That means A stands for amplitude, L stands for loudness. It is quite obvious that if the amplitude of the sound is more, the sound is said to be louder. If the amplitude is small, then the sound is said to be softer. Second, it depends on, it is inversely proportional to the square of the distance from the source of the sound. Loudness is inversely proportional to the square of the distance from the source to the perceiver. So D stands for the distance from the source. Any source is producing the sound due to the vibration, and you have a receiver. So distance, if the distance is less, the sound will be louder. It is quite obvious. If the distance is very far, the sound will be softer. Third factor, it depends on the surface area of the vibrating body. It depends on the surface area. Suppose if I write loudness is directly proportional to surface area. SA stands for surface area. It is quite obvious. If the area of the vibrating body is big, then it will produce a loud sound. For example, if you look at the bell in the school, or you look at the bell in the temples, or church, etc., it is a huge one, so that it produces a loud sound. The bells in the school especially, so that the surface area of the vibrating body is big, and the loudness will be more, directly proportional. More the surface area, more the loudness. Then the fourth factor is, it depends upon the density. Loudness is directly proportional to density of the vibrating body, or density of the medium. Okay, if the density of the medium in which the body is vibrating is more, then it will produce louder sound. The fifth factor is, the loudness of a sound depends on the presence of the resonant body. It depends on the presence of a resonant bodies. Okay, now our body, in the last class we have already discussed resonance, where you have the natural frequency of the vibrating body and the frequency of the applied force. If the two frequencies become equal, then the resonance is occurred. So when in the presence of the resonant body, if you have another body where it is vibrating or producing the sound, then the loudness will obviously increase. So basically these are the key points which you have to write down. If you can also refer to page number 162 or 100, I think 64, 65. There you will find in detail, but you just have to learn the key first sentences. So these factors on which the loudness of a sound depends are very, very important. Now we have the other two factors. The second factor, or the second characteristic, sorry, other two characteristic. The second characteristic is pitch, and the third characteristic is quality. That I will discuss you in the next class, that is probably tomorrow. Please do the assignments, go through all these notes, and you have to write it down in a textbook and send it in my WhatsApp group. Thank you very much.